Alright, so we're about to knock off for the night, and here's the update. So this side here, you can see it chatters a lot, and we don't know what's causing that. We think it might be related to the Gibbs, but we're not sure. But you can see the chatter marks look horrible. But then look when it turns the corner. All of a sudden it goes to a nice, pretty, smooth as could be surface finish. I mean, this looks great. Look how smooth. It's hard to, I don't know if that shows up on a camera, but man, that's slick. That looks nice. You come to this side, it's a little rougher, but not much. But it does sound different, you can tell. But this one side, for whatever reason, is horrible. And it's not just the material. This machine's always done this. So, we don't know what's causing that. I would gladly pay money for someone to tell me. I mean, look at this corner. Yeah, so if you look at this corner here, you can see the surface finish goes from like pretty to rough. Like over here, sorry it's hard to film the camera, but that's pretty. Makes the corner, and it gets terrible. So we don't know what's causing that yet. Maybe it has something to do with the y-axis Gibbs, or maybe the x-axis Gibbs. We don't know. But what we do know is that if we figure that out and we can get them all to look like this looks great. This is nice and smooth. And we were just roughing, so if we did a finish pass, it'd be even better. So there is hope. But we're going to kind of think about this more, see if we can get some more advice and get this going. Hey guys, so I got a tripod set up finally, so I'll have some better shots coming. Alright, so I'm going to try to explain what might be happening that's causing all this weird chatter and vibration on the machine only when you're cutting a certain way. So what we're noticing is when we go across cutting this way, everything seems okay. Back here, everything seems okay. When we go here, it's awful and it chatters like hell. And over here, it chatters some, but it's not quite as bad. So let me show you what we're thinking. So if I were to rotate this and look at it in this direction, so this is the one that makes the worst noises, is when we cut this way. Okay, so what John proposed is what should happen is the end mill is basically like this. It's flat, and it spins as it goes across, and it cuts metal, and that's fine. But what would happen if it was tilted this way? Tilted this way. So the cutting edge would be up here, which would be cutting the metal, and the very back of the cutter, the part that's actually touching the paper, it would kind of be dragging against the bottom. And that might be, so imagine if it was doing this, you would get a scratch mark. Let me see if this kind of shows up on a zoom. Yeah. So see how I kind of scratched the paper with this little tape measure? Those scratch marks, like if this thing was crooked and it was dragging like this as it went across, and I kept doing that, see how I create all these weird scratches in the bottom of the material? Well, that's what we actually see on the part. So the idea is, if this cutter were crooked, essentially there's metal that's going under it that's not been cut yet because this is crooked. Let me get you a better camera perspective. Okay, so the theory is, instead of this end mill being flat, it's tilted up like this and it's spinning. And so underneath the end mill, material can just go right under it. So imagine if this were some of the metal. Then as the cutter goes, that part underneath is like a wedge that's not getting cut, and it's running into the bottom of the end mill. So the bottom of the end mill is trying to cut, and they're not really designed to cut this way. So what would happen is the bottom, it would start hanging up, and it would kind of push the end mill up like this. And since it's spinning, it might hook and try to go this way. So if it went this way, and there's a wall of metal here, now you would run the end mill into that wall, and you would get scratch marks in the wall. So if this were happening, you'd have scratch marks in the bottom, like this, and you'd have scratch marks against the wall. And that's what we're seeing. So this may or may not be the problem, but if it's the problem, what we're actually seeing on the part matches what you would expect to see. Now, let's look at it from the other side. So we're going to look at the side that chatters less, not nearly as bad. So we just spun the paper around 180 degrees. So on this side, our cutter would also be crooked, but it would be crooked the other way. So now, when you spin across, if the leading edge is actually cutting all the metal, and back here, you would have air as the end mill goes across this way. So in this way, it's not dragging. You don't have that same problem. And here's the other thing. So the way this thing's cutting, if it were to grab and do like this, it would pull itself away from the material, like this. So it wouldn't run into the material as it's cutting. If it ever did grab the bottom, it would just pull away. So this wouldn't cause much of a surface finish problem on the very back of the metal. So over here, if this was crooked, it would still cause some issues. You want this cutter to be flush, you know, and if it ends up being like this, that's harder on the cutter, but you wouldn't expect it to scratch the bottom very much, and you wouldn't expect to see any chatter on this side, and that's what we see. But you would expect it to not be as smooth as if this cutter were just straight up and down the entire time, the way it's designed to operate. So it's an interesting theory. John brought this up, and you know, the guy might be right. I've never thought about this. In fact, I thought I had the machine trammed in correctly, but I actually ordered the stuff to measure this and set it correctly, the correct tools. I never had the right tools, so I just kind of used what I had in the past. And I'm starting to think maybe that's what it was. Maybe this thing's been trammed in wrong, and it's been that way for a long time, and maybe that's what's been causing all of our issues, you know? So the parts, the dial indicators have already come in, but unfortunately, the other part, USPS has it, and it'll probably be like the second week of December. No, just kidding, but it says it's going to be Saturday. So we're going to have to wait for that to come in. But as soon as it gets here, I promise you guys, I'm going to go straight to the shop. We're going to hook that stuff up, and we're going to measure everything and find out if this machine's crooked. So if John's right, the spindle and the table are not square with each other. So basically the spindle would be kicked this direction relative to the table. And the table would move this way, and since the spindle's moving not perpendicular, that would explain all the weird stuff we're seeing. So we are definitely going to measure that. And what we're hoping for is that we will measure it, we'll find a problem, and it'll be exactly this problem, the y-axis tilted in this direction. That would explain what we're seeing. So fingers crossed that this ends up being our main problem. We do know we got to adjust the Gibbs some more. We're going to probably get that done before this part comes in, and that way we'll have that kind of fixed, and that'll be like a known, you know, the Gibbs are good, and whatever improvement we see from this point forward will be from tramming in the machine. So anyway, that's pretty awesome news. If it turns out to be I told John if this fixed it, I'd give him $100, and after he turned that down, I told him, well, I'll buy you a steak dinner. So if this works out, it's going to be awesome, because this is kind of what we need to be able to make these billet caps. We got to get this machine cutting good on all axes. All right, guys, y'all take it easy.